Let's talk about octal now. Octal is very similar to binary, except the fact that instead of base 2, it's base 8. So my numbers can only go from 0, 1, 2, 3, 4, 5, 6, 7. So no digit larger than 7 exists in octal. So we're going to make our table. And as I said, instead of base 2, we're going to use base 8. So 8 to the 0, 8 to the first, 8 squared. 8 to the 0 is 1, 8 to the first is 8, 8 squared is 64. Now, we traditionally in this class won't go up to a fourth digit, which would be 8 cubed, which is 512. So as long as my number is less than 512, my answer is going to be a 3-digit number. Or smaller, it could be 2. So let's look at 333. So we're going to go from decimal to octal now. So 333. And I want to start with my largest number. So I'm going to start taking out 64s. And I'm going to see how many 64s I can remove. Take out a 64. It's a 9. It's a 6. That is a 269. Take out 64 again. Gives me 205. Take out 64 again. Gives me a 141. Take out another 64. Gives me a 77. And one more 64. Leaves me 13. So I took out 1, 2, 3, 4, 5 64s. So I'm going to put a 5 in the space that matches up with the 64s. Now I'm going to remove the 8s. So minus 8 gives me 5. I can only take out 1 8, so I'm going to put a 1 in the 8 column. Now how many 1s can I take out? Well, I'm not going to subtract 1 at a time. We can see I can take out 5 1s. So 333 in decimal is the same thing as 515 in octal. Now, let's go the other way. Let's go from octal to decimal. And again, remember, I'm going to deal with 3-digit numbers. So let's do 165. Now, the key thing to remember here is that this first spot is the 64s, the second spot is the 8s, and the third spot is the 1s. So I have 164, I have 6 8s, and I have, 164, 6 8s, and 5 1s. Now I'm just going to add those numbers up. 1 times 64 is 64. 6 times 8 is 48. 5 times 1 is 5. 12, 17, carry the 1, 10, 11. So 165 in octal is the same thing as 117 in decimal. Hope that helps.